Hey guys, welcome back to Tips and Tricks. This is Viren here, and here's yet another networking fundamentals video.
This is my video number 3, and if you have seen the other 2 videos, I'm sure you would be knowing about these ground rules here. So I'll move on to the second slide directly. So these are the things that we will cover in this video. What are the different network models? Why do we need them? What was the first network model? And what network model do we use today? So before going to these, I just wanted to tell you something. All right. So what happened was, all this while we know that network is all about connecting a point A, and that is a source, and it goes to B. So we simply know that data sent from here travels and goes to B. But what happens in the underlying in communication? How is that happening? So to understand this, the ISO came up with a model called as OSI, and this model had 7 layers. The first was application. Just excuse me for my writing. Yeah, and anyways, you will see these in the later on slides. Presentation, session, transport, network, and then there was a data link layer, and then the physical layer. So basically what they were trying to do is, so let's say that you had 2 points A and B. So the application layer basically tells you this is the layer that you work on. This is the layer that you give instructions to the computer to send the data from A to B. And to understand the entire transmission that was happening, this layer model was introduced. So you know that the application layer is the user layer. Now this presentation layer is basically the layer which does the encryption and decryption, encoding, decoding, and also does some compression of the files. So when you think of presentation, just think of as a PDF file or any other formats, JPEG. So basically this layer maintains and ensures that when the data goes from A to B, this presentation is maintained. So when the data goes from here onto the other side, the presentation layer on the other side maintains that the data is presented as it was sent. So a PDF sent should appear as a PDF here and not something else. Alright, the session layer is responsible for maintaining the connections, establishing, maintaining, and tearing down the connections between the 2 points. Transport layer controls the data flow. That is, if the data is sent in the order 1, 2, 3, 4, these are the data chunks, then the other side of the transport layer should also rearranges and ensures that the data is received in the same way. And let's say if the chunk 2 was missing, then what happens was this is acknowledged here. That 2 is missing, then instead of sending again 1, 2, 3, 4, it will simply just send 2, and then it will acknowledge, and then it will start sending the data bits. And you'll know what the whole process is. This is called the windowing technology, and we'll understand this later. Network layer is responsible for routing. So this is the layer where all your routers and layer 3 switches, routers and layer 3 switches act. This layer is responsible for finding the IP addresses. So the intelligent routing or the transmission is done at this layer. Now let's talk about data link layer. Now this layer is responsible for checking, doing the finding the IP destinations basis the MAC address. the medium access control, which is your hardware address. This is where the switching is done. The switching is done at this layer. So when you talk about switches in your office connected to the various computers, they are working at this layer. The moment you want to go, go for an internet IP address like yahoo.com or google.com, then the routers come into play and the third network layer starts working on that. And physical layer, I mean, it's pretty much simple. This is where all the data is traveled through the cables in the form of electrical signals, that is zeros and ones. This is layer number 7, 6, 5, 4, 3, 2, 1. Just try to understand that this model is just a conceptual model. This was developed to understand how the data transmission is happening. Data in these layers is simply called as data. Data at this layer is called packets. Data at this second layer is called as frames, and data at physical layer, any idea? Well, it's all bits and bytes. Alright, so just imagine when you send the data from A to B, what's happening is this data goes to every layer and is still data at transport layer, gets converted into packets, and the third layer gets converted into frames, into the second layer, and gets converted into the bits and bytes on the last layer, and travels to the next side. So what is happening is the first 4 layers, that is data. This is encapsulated under a new packet at the network layer, which is these are the packets. These packets again get encapsulated in frames, and then these frames get converted into zeros and ones and are transported from the physical cable to the other end. Now on the other hand, the decapsulation happens. So the zeros and ones are again arranged to form as frames. So the frames is thrown out and the packet is taken. Now the packet is thrown out and the data is taken, and this data is again arranged in the presentation by the presentation layer and given to you on B. So something like this happens, and so once again, this is a conceptual model to understand how the transmission is happening from one point to the other. Alright, let's move on to our slides. So alright, so these are the 2 models that I'm sorry, I didn't mention the second one. So the OSI was developed by the ISO, the Open System Interconnection, that we've already seen. Now there was already a model even before the OSI model came up, and that was called as the TCP/IP model. Now this TCP/IP model is also called as the DoD model because the US Department of Defense came up with this model. And the difference between these two is that the TCP/IP model still exists today, and this is not a conceptual one. I mean, this is the one that we are using today, and you'll know what's the difference in the later slides. All right, so as I already explained, on the OSI model you have the 7 layers, and these are the roles of each layer. The application provides the user interface. So this is the one layer which talks to the network through the below layers. Presentation layer uses a common language. Again, it controls the presentation, PDF, JPEG, and all the formats. Session, it controls and maintains the sessions between the points A and B. Transport allows the appropriate delivery control flow that I was talking about. The chunks, getting acknowledged if 4 are sent from here on the other side. Ensure that all are received. Network layer is all about doing the intelligent routing, finding out where the B is. Data link layer, now I told you about data link layer that this does the routing within the LAN. So this only acts on the MAC addresses. So this data link layer is again divided into two parts, the logical link control and the medium access control. We will study these in detail later on, but for now just understand that this layer is responsible to check the addresses of the destinations on the basis of the MAC address. The last layer, as you know, it's all about this is where the signals travel, the electrical signals, all zeros and ones. All right, so these are the protocols that act at different layers. So you may have heard of some of them, like FTP or ping. Ping stands for the packet internet groper. We use this to see if we have any connectivity. Let's say if the internet is not working, the very first thing we do is we ping the IP address of google.com, and we get some information whether it's reachable or not, and that information is also worked upon by ICMP, which is I'm sorry, that information is also worked by ICMP, which is Internet Control Message Protocol. So this tells us as to this does an echo. The moment you get the replies through the ping, those replies are actually coming with the help of this ICMP, Internet Control Message Protocol. If you are confused for now, just understand that there are different protocols working at different layers, and remember, we'll learn a lot of protocols. So some protocols are made up of a stack of protocols. So let's say we are talking about I'm just giving an example. So let's say we are talking about PPP or something, L2TP. This may again in turn be made up of various protocols, but in general, protocols is nothing but an organized way, or a communication, or a language, or a set of instructions to execute a particular work. So FTP, HTTP, you know that whenever you request a website, HTTP is there. So HTTP works at the application layer. So this is just to give you a sneak peek as to what protocols work at what layers, and there are still lots of other layers, but for the time being I just wanted to give you a small brief which layers work at which layers use which protocols. Okay, now about the hardwares. So as you can see that the hardwares come into play only from the network layer. Now the network layer is a place where the layer 3 switches and routers work. Don't get confused with switches and layer 3 switches. Switches are meant to work at layer 2 because they just look at the MAC address. And we have intelligent switches which can find out the IP addresses based on the IPs instead of the MACs. Those are called layer 3 switches. But again, layer 3 switches and routers is almost similar. There are minor differences which we'll cover, but you can call routers as a layer 3 switch as well. Physical layer, at this place all the cables and modems and hubs, they act. Now hub is basically just a repeater. In olden days they used to have a hub and they used to connect 10 PCs to that hub, and all the 10 PCs could speak to each other via this hub. This was basically just doing the amplification of the signal coming from one point and sending it to the other. All right, moving on to the next slide. Now, as I told you that even before the OSI model came up, the Department of Defense had already come up with a model called as TCP/IP model. They came up with this model to ensure that they have a network connectivity in case of war times if they lose their communication. Let me just bring up the scratchpad once again. So basically what they were doing was, let me just okay, so basically what was happening, let's say they had a point A and they had a connection from one place to the other, B. From B they had another connection to C. Let's say they had a point D and something like that. So basically the communication was going from here to here. Let's say due to a bomb or something, let's say this line was destroyed. So they just wanted to ensure that the data from A still reaches C through the other path. This was the whole idea for them to come up with a model of TCP/IP, the model which could recover or still maintain the communication. That is how all the internet started. All right. Okay, back to the slide. So, and this model just had like the 4 layers: the application layer, transport, internet, and network access. This layer had come a long time ago. Some people can't even imagine, and if some of them know about this, that's a good thing. Way back in 1969, the Department of Defense commissioned one agency called ARPANET. Stands for Advanced Research Projects Agency Network, something like that. So the DoD asked the ARPANET to come up with this kind of communication or some kind of transmission technology, and ARPANET in turn came up with this model. So initially there was no TCP/IP, it was just TCP, which was doing the transmission from one place to the other. Alright, so anyways, from exam perspective, you need to remember that transport layer in OSI can also be called as host-to-host layer in TCP/IP model or DoD model. The data link and physical, they combine, and they were separated, but earlier they had a network access layer. So these two layers are actually network access in TCP/IP model, which is also called as the link layer. The application layer is called as the process layer, which kind of covers these 3 layers in OSI model. So let's say there can be a question as to which layer in TCP/IP model is responsible or acts like application or acts as a combination of application, presentation, and session in OSI. That would be process layer. Alright, I guess that makes it very clear. So I guess we've covered both the models, but just remember the TCP/IP model is something which exists today and we use it today. This is just a conceptual model or a reference model to understand how the communication takes place or how the transmission takes place from point A to point B. Moving on to the next slide, I just wanted to give you a key notes. Once again, OSI model is not a regulation but just a reference model. So let's say if some company wants to come up with some kind of protocol, they will just understand this as to how their protocol would fit all these layers. All right. And that's why I've mentioned here that although OSI is not always strictly adhered in terms of keeping related functions together in a well-defined layer, many if not most of the products involved in telecommunication make an attempt to identify themselves in relation to this model. So they will come up with some protocols or some equipments which will fit this model. So this will give them some guidance as to how they will design something, what in their product will do the job of transportation, what in their protocol will do the work of network layer, these sorts of things. The second layer, the DoD model, which is actually the earlier layer. I'm sorry, the earlier model than the OSI model. So TCP/IP is an industry standard, and this is what we use today in the LANs and WANs. There were 4 versions of TCP, and the reason I've just mentioned TCP, I told you there was no IP earlier, and I'll tell you, you'll see it in the later slides. There was TCP 1, version 1, version 2, and version 3. Yeah, this is also, I'm sorry, TCP version 3, and then came up TCP/IP version 4, which are still in use today. Okay, so I just did some research and found out these. Like I said, 1969 DoD commissioned ARPANET, which stands for Advanced Research Projects Agency Network. The project was to come up with a high-speed network communication. 1972 they came up with this protocol Telnet, which is really even before TCP was invented, they came up with Telnet. We will talk about Telnet, and it's of big use. Sitting in one place and logging into your routers and switches, how it helps you. 1973 FTP, that is file transfer protocol, was invented. Now the landmark in 1974, these two guys, Vint Cerf and Robert Kahn, really amazing, guys. They came up with TCP. That is the way to transfer data from point A to point B. Not many people know this. These are the two people, Yogen Dalal and Carl Sunshine. They were actually the students of windsurf. And windsurf, along with these two people in Stanford, they published the first specification of TCP in December 1974. Now, so TCP was being used. 1975, a two network connection was performed, point A to point B, and then in 1977 TCP was again revised to version 2. It was documented in IEN2, that is Internet Engineering Note number 2, a kind of a reference model, just like we have RFC for IEEE now. If you don't know what IEEE is for now, just that's okay, but if you want, you can just do some research. Okay, so TCP version 2 came up, and then in November a 3 network TCP was also tested. Now there's another big guy, John Postel. In 1977 he found out that the TCP was doing a lot of job. It was finding out the position of the point B also. I'm talking about the A and B again and again, just to give you an idea. So the TCP was doing the job of finding about the location of B, and it was also maintaining a connection between the 2 points. So let me just go back to this model. So basically TCP was acting here. So think of the same thing on the other side. So this, or let me just bring up this. So basically what was happening, those 7 layers from point A to B. Now TCP or layer somewhere at layer 4, TCP was maintaining the flow control here, and it was also trying to find out where B is. That is, it was doing the job of the network layer, that is routing. Network layer is responsible to find out where B is on the basis of IP. So John Postel found out that TCP was doing a lot of work, and after this commence in 1978, even before 1978, I mean in 1977 itself, they started working on tearing down TCP, and then they isolated, they divided the TCP into TCP and IP, and the IP now works at layer 3, that is at the network layer, to find out where the position of B is. So that's how TCP IP came into play. And in 1980, the first TCP IP version 4 was created, which we still use today. 1982, DoD declared TCP IP as the standard for the military computer networking, and by another 7 years, everybody was using the internet using this amazing technology, TCP IP. So in these, if somebody is wondering what's happening between 82 and 89, this TCP IP, which was being by military, it was still used in these 7 years by educational institutions, or very few people were given access to do this connectivity from one point to the other. But by 1989, everybody was using this, and the commercial internet service provider came into place. The first ISP known to me is World. So I have found out all this information through the net, and if somebody thinks that this is not appropriate, please feel free to give your comments, and I shall change it, or we can talk about it. That's about it, guys. We come to an end of this video. Just hold on. If you're serious, if you've come here so far to video 3, you're serious, and so am I. So once again, thank you for watching this video. We'll talk about a lot of networking, and stay tuned for the video number 4, and don't forget to subscribe this. Thank you.